Hello, good morning students. So today we will be starting distributed generation and smart grids. In the previous classes we had enough briefing about the subject, and we are going to start module 1, and we will see today the distributed generation. What are the different distributed generators? What is distributed generation? Distributed generation means small, modular, decentralized, grid connected or off-grid energy sources located at or near the place where energy is used, and mostly they are renewable based sources. Or in short, distributed generators are distributed along the load, or they will be very near to the load, or they will be installed near the customers. For example, the solar panels installed in institutions, houses, industries, etc., micro turbine, storage devices, wind turbines. So these are examples of distributed generators. We will see different DG technologies. DG stands for distributed generation. The first one being the micro turbines, combustion gas turbines, fuel cells, solar energy or PV photovoltaics, wind turbines, bioenergy and fuels, combined heat and power system or CHP, Stirling engines, marine and hydropower, geothermal. We will see each one of them briefly. So starting with micro turbines, they are turbines in the range of 25 to 500 kilowatt, and the size is roughly about the size of a refrigerator. The basic function of a micro turbine is to provide energy. How they provide energy is, these turbines work with some fluid, and these fluids convert the flow to a rotational energy, and this rotational energy coupled with a generator produces electrical energy. The mechanical output of this turbine can also be used in various other applications. Next one is the combustion gas turbine. In a combustion gas turbine, a combustion takes place. So some gas or some fluid is burnt, and the expansion caused by this combustion is used in rotating a turbine, and that turbine coupled with a generator produces electrical energy. So you can see a compressor upstream to the combustion chamber, and a turbine downstream to the combustion chamber. Next one is the fuel cell. A fuel cell is an electrochemical cell which converts chemical energy into electrical energy by way of redox reactions. They are different from batteries because they need continuous source of fuel and oxygen to sustain the chemical reaction. Fuel cells are used in modern buses. Coming to solar energy or photovoltaic PV. A solar panel consists of a series of photovoltaic cells, and each of this photovoltaic cell produces electricity when sunlight falls on it. Next one is wind turbines. Wind turbines make use of the power of wind, and this energy is converted into a rotational form, which is used again to rotate the armature of a generator and in turn producing electricity. The next one is the bioenergy and fuels. Biomass is any organic material which has stored sunlight in the form of chemical energy. It can be wood, leaves, wood waste, kitchen waste, straw, manure, sugarcane, or any other byproduct from a variety of agricultural processes. Bioenergy is energy derived from biological sources or from biomass. The best example is a biogas plant commonly found in homes. The organic waste from the kitchen is the input to such a biogas plant, and it produces cooking gas which can be connected to a biogas stove. The next one is the combined heat and power system. When we have a power system means there is a turbine or an engine coupled with a generator, and this engine or turbine is driven by some fuel, and when the turbine rotates, the generator produces electricity which can be connected to the grid, or it can be connected to your home or to the load in general. Now when the fuel is burnt, it produces hot exhaust gases which goes to the atmosphere. So it's a wastage of energy. If this heat can be recovered by using some heat recovery unit, or this heat can be used for some useful application like water heating, then such a system is called combined heat and power system. By using a CHP system, we can increase the efficiency of a traditional power plant from 45% to 80%. The next one is a Stirling engine. As you see from this animation, it consists of a piston and a cylinder, and heating the air inside the cylinder pushes the piston to and fro. So basically the heat energy is converted into a linear motion, and this linear motion can be converted into a rotational motion by using proper links, and then this can be coupled with a generator to produce electricity. A Stirling engine can be effectively used to harness solar energy. You can see the picture below. A solar concentrator concentrates the heat energy to one point, and this heat is used by the Stirling engine, and Stirling engine is coupled with a generator which produces electricity. Marine and hydropower. Hydroelectricity is very common in Kerala. You might have heard about a lot of hydro power generators in Kerala. The water stored in the dam is used to rotate a turbine, and this turbine is coupled with a generator to produce electricity. This is a renewable energy does not produce any type of pollution. Small hydropower generation, or we call it mini hydropower generation, is increasingly used now to produce small quantities of energy, hydro energy. Marine energy can be a tide from the tides or from the waves. During high tide, the water level increases, and this water level, while this water stored water, when it goes back to the sea, rotates a turbine fitted inside a tunnel. As the turbine rotates, the coupled generator starts working, producing electricity. Similarly, the wave power can be used to rotate a shaft or rotate a turbine, and which can be again coupled to a generator to produce electricity. We can also produce solar energy and wind energy by installing solar panels over the seabed, and similarly by installing windmills in the sea. And finally, coming to geothermal energy, as you all know, below earth, as we go deep into the earth, the temperature increases, or we will have a heat reservoir beneath our soil. And if this heat reservoir can be used to run a turbine, which is coupled to a generator, we can produce electricity. So with this, we will end up this session. We will see again with another topic in the next session. Thank you.